Assalamualaikum and hi everyone. This is video for tutorial 13 thermodynamics. And before we go to the example, so we go through the summary for chapter 13 about thermodynamics. So, di dalam this chapter, what the important adalah yang pertama, you can differentiate between the work done on the gas, okay, work done on the gas and work done by the gas. Okay, kebiasaannya hanya satu yang kamu perlu ingat iaitu work done on the gas. Dan work done on the gas ini adalah bertentangan dengan definition of work done by the gas. Okay, kita tengok the definition of done on the gas. Okay, work done on the gas ini adalah disebabkan kerja yang dilakukan kepada gas, okay, by the external force. Alright. Okay, seterusnya work done on the gas ini adalah due to the gas compression. Okay, that's why if the gas compress, alright, so gas compress, so that's why the volume is decreased. So if the volume decrease, so the change of volume, okay, change of volume, dia akan jadi negative. Okay, so kita letakkan simbol negative in the calculation to make the W is positive. Alright. Okay, the gas due to gas expansion, okay, due to gas expansion, volume increase with delta U is positive, so the W is negative. Okay, what is gas compression and gas expansion? Kita bayangkan gas itu diletakkan dalam satu piston. Okay, dalam satu piston. Alright, this is gas. Okay, if the gas is compressed, okay, bila gas itu dikompreskan, okay, the volume, alright, the volume initial itu tadi, okay, the volume initial itu tadi pada tahap ini dia sudah menjadi volume initial, dia sudah menjadi volume final di sini. So the change of V, okay, it will become V final minus V initial, so dia akan become negative. That's why we put the negative here to make our W is positive. This is due to gas compression, but for gas expansion, of course, the change of volume is positive, so we will get the W is negative. Okay, while for the gas, the work done by the gas, okay, ataupun work environment, we call it as work environment, it is against the external force. Okay, due to compression, the work have to be done by the gas to against the compression, so work environment kita akan jadi negative. But due to expansion, the gas do not need to do work to against the external force, so work environment kita akan jadi positive. Okay, alright, and this is you must remember, okay, if there is no change in volume, the work adalah akan menjadi 0. Alright. Okay, this is the summarize about the process thermodynamics. Okay, there are 1, 2, 3. There are 4. Okay, there are 4 process in thermodynamic. First is isothermal. Second is isovolumetric, or we call it as isochoric. And third is isobaric, and fourth is adiabatic. So for isothermal, okay, this is isothermal. For isothermal process, okay, this is the graph for PV diagram for isothermal. Okay, ini curve for isothermal. Alright. Okay, kalau kamu tengok dia tidak ada anak panas ini kan, so bila dia isothermal, it can be isothermal compression or isothermal compression or expand, compress or expand. Okay, dia boleh compress and expand. Isothermal can be compression, isothermal compression, and it can be isothermal expansion. So if isothermal compression, they compress, so of course our volume ini dia akan decrease. So if volume decrease, so our anak panah ataupun kita punya error di dalam graf kita nanti pastikan ada error supaya error anak panah ini ataupun error ini menunjukkan either the isothermal is compressed or isothermal is expand. So if isothermal compressed, the volume is decreased. So anak panah kita akan dia decrease lah from initial to final. So if the isothermal expansion, so the error for expansion is right. So the error for expansion is this one. Okay. Sorry. Okay. So for isothermal expansion, expand, so volume is increased, so dia punya error dia akan jadi beginilah. Okay, dia akan bertentangan dengan compress. Alright. Okay, for in isothermal compression, okay, okay, kita balik semula. Okay, in isothermal compression, what important di dalam isothermal expanse or isothermal compression is constant volume. Okay, isothermal maksudnya dia mempunyai satu constant volume. So bila dia constant temperature. So if dia adalah constant temperature for, so our internal energy, okay, change of internal energy will equal to 0. So Q equal to W due to first law of thermodynamics, change of U equal to Q plus W. If our U is 0, why U internal energy equal to 0? Because internal energy is depends on the temperature. Okay, remember the equation of internal energy, 3/2. This is for ideal gas, monoatomic ideal gas, 3/2 nRT. Okay. Due to constant temperature, so our temperature is equal to 0. That's why our internal energy equal to 0. That's why Q equal to W. Okay, dia ini mematuhi the Boyle's law in the law of kinetic theory of gases. Okay, second process is isovolumetric or isochoric. For isovolumetric, okay, easy to remember, isovolumetric, yang constant adalah volume. Alright, constant adalah volume. So jadi apabila kita tengok pada kita punya PV diagram, yang which one is the isochoric, constant volume, this is the equation for this is the curve ataupun the line for isovolumetric. Okay, kalau kamu tengok dia tidak ada error juga kan, tapi in the question, apabila satu soalan yang di given, you must letak the error untuk menunjukkan isovolumetric proses ini either dia compress or expand, same with the isothermal. If the isochoric is compressed, okay, dia tidak ada pula, sorry dia tidak ada compress or expand because why? Because the volume is constant. So volume is constant, so of course our W, okay, W kita adalah equal to 0 because work done satu gas, okay, work done is equal to area under the graph. So if you look here, okay, if you look here, dia tidak ada area under the graph. So that's why W equal to 0. So kita kembali kepada the first law of thermodynamic, change of W equal to QW. Q plus W is if W is equal to 0. So W change of U equal to Q. Okay. Dan dia mematuhi the gas law ada dalam Charles law. For isovolumetric, okay, dia boleh mempunyai increase the pressure or decrease the pressure. So if they increase the pressure, kita punya anak panah, okay, kita kena letak ke atas lah if the pressure is increased. If the pressure is decreased, alright, okay, if the pressure is decreased, so our, so our kita punya anak panah dia adalah ke bawah tu yang kuningnya. Sorry, contoh pula. Anak panah dia ke bawah. Alright. Okay. Okay, after that we go to the third process is isobaric process. Alright. Isobaric process adalah constant P. Okay, this is the curve, this is the line for isobaric process yang di mana the isobaric process it can be expand or compress. Ini dia boleh jadi expand, dia boleh jadi compress. Maksudnya isobaric compression or either the isobaric compression or isobaric expansion. Okay, is isobaric expansion, the piston. Alright, bila they expand the piston, of course the volume is increased. Alright, if they decrease the piston, they compress the piston, so of course our our volume is decreased. Okay, isobaric is constant P. So if the isobaric is constant P, the P delta U equal to Q negative. Okay, dalam in bracket negative P times V. This is the work done. Okay, work done by environment. That environment to make it positive lah di sini. And the last process is adiabatic process. Adiabatic process is nothing is constant but heat equal to 0. Ini di dalam isolated ataupun closed system. Dia bukan asal sistem, dia closed system. Yang di mana dalam closed system dia tidak membenarkan the gas, the heat or the energy transfer in or transfer out. That's why Q equal to 0. If we back to the first law of thermodynamic, when our Q is 0, so our change of internal energy, change of U equal to negative W. Okay, this is why is negative W. Ini menunjukkan dia adalah work environment lah. So if it work on the gas, okay, the equation is this one to become it positive. Alright, positive, dia akan jadi work done on the gas. Okay, ini adalah contoh-contoh the curve for process in thermodynamic. Okay, adiabatic dia boleh jadi compress and expand. So if dia compress, dia akan anak panah dia ke atas lah. Bila dia expand, so anak panah volume dia akan increase. So anak panah dia akan bertentangan dengan compression. Okay, this is the equation, the important equation that you must remember for ideal gas. Okay, first law and thermodynamic process in ideal for ideal gas. So for isobaric process, ini tadi the change of internal energy, the equation yang kita boleh guna this one, and for Q this one. Okay, because why the change U and Q, this is the same equation, tapi nilai CV and CP dia adalah, for Q adalah dia menggunakan CP, but for change of internal energy dia menggunakan CV. Okay, nilai CV and CP ini adalah constant, dia akan diberilah. Okay, refer the lecture note before. Alright, yang telah diberikan. Okay, for the work done adalah negative P delta V. Okay, this is for the isobaric process where the pressure is constant. Okay, for adiabatic, okay, adiabatic process, Q is equal to 0, so Q equal to 0, jadi dia the equation for change of internal energy NCV delta T, and for W is delta W equal to delta U. For isovolumetric, V is constant. Okay, V volume constant, so work done kita adalah 0 because we know W is equal to negative P delta V. V equal to 0. That's why W kita equal to 0. So Q equal to delta U. Okay, that's why bila kita punya delta U is equal to NCV delta T, jadi Q kita adalah sama nilai dengan delta U or the internal energy. Okay, alright. For isothermal process pula, isothermal process is temperature is adalah constant. So if the temperature is constant, delta U, okay, change of internal energy ataupun internal energy ini bergantung kepada temperature. Okay, what internal energy? Saya sudah terangkan the definition of internal energy. That's why U kita ini, okay, internal energy kita adalah 0 because the internal energy it depends to the temperature. Okay, jadi kita punya Q is negative W, and so isothermal the work done for isothermal, this is the equation we use for work done. Okay, work done on the gas. So in general, okay, for this all process in thermodynamics, okay, the equation for internal energy adalah NCV delta T. For Q adalah U delta U minus W due to first law of thermodynamics. Okay, alright. Dan juga W, what is W? W is usually is area under the graph. Alright. So this is the summary, the simple summary for thermodynamic process. So this is the so we go to the equation. Okay. Alright, kita pergi pula kepada the example. Okay, this is the example. We look for example number 1. Okay, example number 1 dia kata apa? Sketch a PV diagram and find the work done by the gas during the following stage. Dia minta yang kita pertama, kita sketch PV diagram, dan second is find the work done by the gas. Okay, bila ada work done by the gas, dia adalah work environment. Okay, yang pertama kita tengok. A gas is expand from a volume A. Kita tengok yang question number A dahulu. Okay. The gas is expand from volume. Volume, dia volume initial, dia expand daripada volume initial 1 liter to volume final adalah 3 liter. So make sure the unit liter you change to unit meter padu. Okay, meter padu. At a constant pressure constant at 3 atm. Okay, jadi kita boleh lukis lah. Okay, kita boleh lukis. Okay, yang pertama adalah PV diagram. Okay, let's tulis dulu lah. Alright. Sorry ya, mungkin dah cantik kali. Okay. Okay, ini 3, 2, 1. Ini in units of atm. And here volume units in liter with 1, 2, lagi 1 sini lah. 3. Alright. Okay. Dia minta apakah work done by the gas. Okay, during the following stage. Okay, following stage yang A itulah. Jadi bagaimana kita punya lukisan? Okay, lukisan kita we use this, inilah line dia. Alright, jadi they expand from the 1 liter to the at the constant pressure. Okay, dan daripada this is the initial stage to the final stage. Let's say we put initial is A, B, D inilah. So anak panah dia adalah seperti ini. Okay. Okay, jadi kita boleh cari dia punya nilai work environment. Okay, work environment for A, P equal to okay, P delta V. Okay, kita punya pressure. What our pressure? Pressure kita 3 atm. So 3 atm ini change to unit Pascal. Okay, 3 atm change if 1 Pascal equal to 1.013 exponent exponent 5. Okay, darab dengan change of 3 tolak 1. Okay, 3 tolak 1 kita dapat 2 liter. So we change to unit meter cube. Okay, darab dengan 1 exponent negative 3. So kita akan dapat the value is 607.8 joule. Okay. For question A. Okay, for question number B pula, okay, we use the ink, lain color ink pula, orange. Okay, dia kata dalam soalan ini, the gas is then cooled at constant volume, okay, until the pressure falls to the 2 atm. Okay, they constant in constant volume until the C lah, ini ada final dia, C. Okay, anak panah mesti buat. Kalau tidak anak panah tidak ada markah. Okay, then dia false the ATM to 2 ATM. Jadi B pula work environment because by the gas, okay, work environment is B to C P delta V. Right, P delta V. Jadi kita boleh dapat okay, oleh kerana volume, the constant volume. So, volume is equal to 0. Okay, volume the constant pada, memang dia ada 3, but because the work adalah area under the graph, so look here, dia tidak ada area under the graph. That's why B is the work environment for B equal to 0. Okay, untuk question number B. Okay, we go to the question number, kita guna color biru pula. Okay, C. Okay, the gas is then compressed at a constant pressure 2 atm from a volume 3 to the 4. Okay, 3, volume 3 to the 4 pada constant pressure at 2 atm. So, from here, initial, go to this final A, B, C, D. Kita let's say this is D. So, anak panah dia compress. Alright, compress. So, kita boleh jawab soalan A, B, C. Yes, expand. Okay. W environment for CD equal to P delta V. Okay, P kita adalah 2 atm, jadi 2. Okay, make sure you change unit to the Pascal unit. Kuasa 3. Okay. 3. Initial 1 tolak 3. Okay, 1 tolak 3 kita akan dapat berapa? 1 tolak 3 kita akan dapat negatif 2. Negatif 2. Okay, kita darabkan dia dengan 1 eksponen negatif 3 meter cube. Okay, so we will get the answer is negative 405.22 joule. Okay. Okay. Settle question number C, we go to the question number D. Okay, we change the ink color to the, apalagi kita mau purple. Okay, question number D. Okay, find, the gas is heated until its pressure increase from 2 atm to 3 atm. 2 atm, they increase 2 atm to 3 atm. Okay, pada constant volume. So, if constant the volume, so W environment for DA equal to 0. The same dengan for B because tidak ada under the graph. The arrow adalah dia pergi ke atas lah. Okay. For E, okay, find the net work done during the complete cycle. Jadi A, B, C, D, E, complete cycle. Jadi kita boleh tambahlah dia punya dia kata net work done. So net work adalah hasil tambah of semua environment net. Okay, equal to 607.8 tambah dengan 0 tambah dengan negatif 405.2 joule tambah dengan 0. Okay, jadi tekan-tekan calculator. So you will get 202.6 joule is the net work during the complete cycle. Okay? Okay. Alright. We go to the question number 2. Okay, question number 2 ni banyak sangat tapi dia senang jawapan ni sebenarnya. Cuma soalan dia sahaja yang banyak. Okay, kita tengok question number 2. Okay. Question number 2A. Kita tengok sama-sama. Okay, kita baca. A cylinder of volume 0.3 meter cube. Okay, saya change dulu saya punya color pen. Okay, a cylinder of a volume 0.3 meter cube contains 10 mole of neon gas at 20 degrees Celsius. Assume neon behave an ideal gas. Okay, ideal gas. So ideal gas, you know, yang pertama dalam question ini yang dia bagi kita cylinder of volume. Okay, the volume of cylinder volume initial dia bagi kita adalah 0.3 meter cube. So you no need to change the unit because dia sudah bagi kita dalam meter cube. Contains neon mole and dia bagi kita 10 mole and the temperature, okay, the temperature initial dia bagi kita 20 degree Celsius. This temperature make sure you change to the to Kelvin, the unit Kelvin, just plus with 273, so you will get 273 Kelvin. Okay, alright. Dia kata lagi behave as an ideal gas. So we know the equation for ideal gas is PV equal to nRT. So equation, the R is constant, yeah, the value of R constant is 8.31 joule per mole per Kelvin. Okay. Okay. Alright, ini adalah information yang dia bagilah. Okay, kita tengok question number A. Alright, what is the pressure of the gas? So because dia mematuhi the behave an ideal gas. Jadi PV nRT, jadi kita boleh cari P equal to nRT over V. Just substitute the value. Okay, 10 R is 8.31, temperature is 293 over volume kita adalah 0.3. So we will get the answer is 8.12 exponent 4 Pascal. Okay. Okay, question B. Settle for question A. For question B. Okay, find the internal energy of the gas. Alright. Okay, internal energy of the gas, because the neon is the monoatomic ideal gas. So the equation for internal energy for monoatomic ideal gas is equal to U equal to 3 over 2 nRT. So 3 to substitute the value of N, substitute value of R 8.31. And substitute the value of temperature is 293. So you will get the answer is 3.65 exponent 4 joule. Okay, the internal energy. Okay, question number A, B, C pula. Okay, settle B and C. Suppose the gas expand, okay, expand ingat expand at constant pressure to a volume of 1 meter cube. How much work is done on the gas? Okay, jadi tengok betul-betul work done on the gas. So work done on the gas. Okay, at the constant pressure. Okay, dia kata pada constant pressure. So work done on the gas W is equal to negative P delta V. This is the equation for work done on the gas. On ingat dia on. So this is the value here is negative. Okay, jadi apa yang perlu kita masukkan the value of pressure. Kita ambil daripada question number A, 8.12 exponent. Okay, exponent 4. Okay, delta V kita adalah dia kata daripada dia expand. Okay, mas tadi. Okay, the gas expand at constant. Okay, daripada volume suppose the gas expand at constant pressure to a volume 1 meter cube. Okay, from the kita tahu the initial kita ini and the final kita adalah V final dia di sini adalah 1 meter cube. Jadi final minus initial 1 minus 0.3. So we will get the answer is negative 5.68 kuasa 4 joule. Okay, the expand dia bukan compress. So if the compress, that's why kita punya work done akan jadi positif. Okay, settle for question number C. We go to question number D. Okay, question number D. What is the temperature of the gas at the new volume? This is the new volume. Dia kata new volume is 1 meter cube. Alright. Jadi dia minta what is the temperature. Okay, ABCD. Okay, PV equal to nRT. Right, the new temperature. Okay, T is equal to PV over nR. Okay, substitute the value the P. Okay, P kita constant P tadi 8.12 exponent kuasa 4. Volume kita di sini dia sudah jadi 1 meter cube over N kita 10 mol, R kita 8.31. So you will get the temperature, the new temperature is 977 Kelvin. Alright. Okay, settle question number D, A, B, C, D, E. Settle question number E. Find the internal energy of the gas when its volume adalah 1 meter cube. Okay, for question E, the internal energy U is equal to 3 over 2 nRT. Okay. Jadi 3/2 10, R kita 8.31. Temperature kita sudah tadi, temperature 1 new pada 977. Jadi kita akan dapat the value of internal energy at 1 meter cube adalah, tekanlah kalkulator kamu, 1.22 eksponen kuasa 5 joule. Okay. Alright, A, B, C, D, E. Okay, kita pergi settle question number E. We go to question number F. Okay, we go to question number F. Before that, we erase dulu. Okay. Okay. Okay, we go to question A. Sudah tadi, sorry. Okay. Question A sudah, B sudah, C sudah, D sudah, E sudah. Kita pergi F. Okay, F. Compute the change in the internal energy during the expansion. Okay. Alright. Dia kata compute the change in internal energy. The change of internal energy is in question number apa tadi F. Okay, change of internal energy, U final minus U initial. So U final kita tadi 1.22 exponent 5. Ni apa ni? Alright, minus initial kita tadi. Kan tadi yang mula-mula kita cari is 3.65 exponent 4. So you will get the answer is 8.55. Okay, exponent kuasa 4 joule. Okay, F sudah. G. Compute U minus W. G. U minus W. Okay, U kita nilai U itu adalah 8.55 exponent kuasa 4. W kita tadi berapa? Negatif berapa tadi tu? Negatif 5.68 exponent kuasa 4. Negatif jadi positif. So U kita akan jadi positif 1.42 exponent 5 joule. Okay, G. H. Okay, H pula. Okay, dia tanya, mass thermal energy, okay, be transferred to the gas during the constant pressure expansion or be taken away. Dia tanya lah thermal energy itu adakah dia transfer, okay, to the gas, okay, ataupun dan pressure itu dia akan jadi expand. Okay, gas during the constant pressure expansion ataupun dia taken away The answer is since, alright, since our internal energy kita refer kita punya internal energy, since our internal energy kita minus W lebih besar daripada 0, okay, because we know the internal energy equal to Q plus W. So dia akan membawa definition of Q equal to delta U minus W. Okay, in first law of thermodynamic. So since our Q ini, okay, bila dia minus, dia adalah positif, dia lebih besar daripada 0. So it is increase in internal energy. Okay, bila Q kita tinggi, dia lebih besar daripada 0. So means our internal energy, okay, internal energy kita juga akan increase. Okay, so there are in increase in internal energy of the gas except the energy transferred to the gas by work. Okay, dia akan by work. Okay, oleh itu additional energy must be transferred to the gas by heat. Maksudnya dia mesti akan ada the additional energy itu dia akan mesti ditransfer to the gas, okay, by the heat. Alright, okay, alright, for settle question, answer question number H, we go to question number I. Compute Q to the internal energy. Jadi A, B, C, H, I. For I pula, apa itu nilai Q? Nilai Q adalah positif 1.4, 2 eksponen kuasa 5 joule. Okay. Okay, and J pula, A, B, C, F, G, I, J. Dia kata, what the symbolic relationship between Q, U, and W? Okay, relationship dia adalah first law of thermodynamic, Q equal to negative U minus the W. Okay. Settle question number 2. Okay, example number 2. We go to the example. Okay, I pick the example number 4. Okay, number 4 apa yang dia tanya? An ideal gas monoatomic. Okay, sekali lagi dia bagi kita this is clue. Okay, an ideal monoatomic gas expand isothermally from 5 meter cube to 1.25 meter cube at a constant temperature of 675 K. Okay, jadi dia bagi kita, dia kata dia ni ideal. So bila dia kata dia ni ideal, Okay, dia ideal gas, so dia kata monoatomic lagi pula kan. Jadi, lagi dia expand in isothermal. Isothermal adalah constant temperature daripada dia punya volume initial, from initial volume 0.5 meter cube to volume final is 1.2 meter cube. Okay, and the temperature is 675 Kelvin, so no need to change the unit lagi lah. If the initial pressure initial dia bagi kita iaitu 1 exponent 5 Pascal. Ini pun tidak perlu saya tukar dia punya unit. Dia memang unit dalam Pascal. If in ATM unit, so you must change the unit to ATM to Pascal. Okay. Question A, find the work done on the gas. So if work done on the gas, W is equal to, okay, the equation for isothermal W equal to negative P initial V initial ln V final over V initial. Okay. Jadi, just masukkan value P is 10 kuasa 5. Volume initial kita berapa tadi? 0.5. Okay, ln V final is 1.25 over 0.5. Tekan calculator, so you will get the answer is, adalah negative 4.58 eksponen kuasa 4 Joule. Okay. Okay. Question B. The thermal energy transfer Q. Okay. B. Kita tahu delta U equal to Q plus W. Jadi Q equal to delta U minus W. Okay, since for isothermal, delta U is equal to 0 because delta U depends to the temperature. So Q equal to negative W. Jadi Q equal to negative W, nilai W kita negatif 4.58 eksponen kuasa 4 Joule. Jadi negatif adalah positif. Jadi kita akan dapat Q kita adalah 4.58 kuasa 4 Joule. Okay. Alright. For question, okay, logik lah kenapa Q dia positif, sebab waktu ini dia kata gas ini mengalami expand. Okay, dia mengalami pengembangan. Okay, dia bukan mengalami compression. Bila dia mengalami pengembangan, of course the Q akan added to the gas lah. Okay, to the system. Right? And for C, the change in internal energy, since the delta U is equal to 0, so delta U equal to, so the internal energy equal to 0. Okay? Okay. Alright. Saya mau bagi ke satu information. Okay. Kenapa kadang-kadang, bukanlah kadang-kadang, tapi kalau kamu tengok, okay, derivation for work done isothermal process, okay, kalau kamu tengok the curve of isothermal process, curve dia seperti ini kan? Okay, either dia expand or compress. Kita tengok contoh ini adalah expand. So expand volume dia akan bertambah. Okay, oleh kerana curve dia adalah seperti ini, alright? Curve dia seperti dia ada curve lah. Okay? Bukan straight line, that's why we use the integration. Okay, the integration lah. Yang ni the integration from W equal to P delta V. Okay? V final, V initial. Okay? Ataupun P dV. Alright, the integration. So, bila kita integrate dia, kita akan dapat this equation. Okay? Alright. Okay, we go to the last question. Okay, last example. Kita tengok soalan ini pula. Okay, tengok the entropy, the definition of entropy. So you can refer your lecture note. Okay, yang saya telah bagi what is entropy. Okay, entropy ini adalah against the law, the first law of thermodynamics. Okay, a styrofoam cup holding 120 gram of a hot water at 1 kuasa 2 degree Celsius cools to room temperature 20 degree Celsius. What is the change in entropy of the room? Okay, sekarang dia bagi kita information. Okay, dia minta the entropy, change of entropy. Okay, change of entropy equal to Q over T. Okay, jadi neglect the specific heat of the cup and any change in temperature of the room. Okay, jadi the information yang dia given adalah mass of the cup is 120 gram. Okay, lepas tu dia bagi kita the temperature initial adalah 100 degree Celsius. Okay, and the T final dia bagi kita 200 to 20 degrees Celsius. Okay, what the change in entropy of the room? Okay, jadi yang pertama kita kena cari kita punya change of T. Okay, kita kena cari the nilai Q. Okay, dari mana kita dapat nilai Q? Nilai Q adalah daripada specific, ingat lagi, the specific heat. Okay, the specific heat capacity. Okay, you must know the difference between the specific heat capacity and the latent heat. Okay, specific heat capacity C lah. Okay, C, what is C and LV? This is latent heat. Okay, this is latent heat for ini adalah what is the definition of latent heat and what the definition of specific heat capacity. Okay, dia ada different. Ini kamu ada belajar di dalam chemistry or waktu kamu secondary school pun kamu sudah diterangkan tentang specific heat and the latent heat. The definition. Okay, specific heat capacity ini dia bergantung kepada keupayaan ataupun capacity sesuatu benda itu menyimpan store the heat. Right? Okay, satu bahan itulah. For L ni pula latent heat dia pula dia adalah satu heat ataupun the value yang digunakan untuk sama ada dia melebur atau sama ada vapor ataupun dia mengalami melebur ataupun apa nama dia tu menjadi pemejal luapan. Nah, begitulah. Alright, kamu boleh tengok baliklah. Okay, beza the latent heat and specific heat. So we know Q is equal to M. Okay, untuk kita mencari nilai Q ataupun heat. Okay, berapakah heat, capacity heat yang boleh store pada sesuatu bahan itu, kita akan guna equation Q equal to MC delta T. Okay, jadi nilai M kita, okay, dia sudah bagi nilai M, the value given untuk M adalah berapa? 0.12, okay, kg, kita tukar kepada unit kg ya. Okay, C specific heat for water. Okay, for hot water adalah constant, iaitu berapa nilai dia? Okay, nilai dia adalah 4186. Betul kan? Kg joule per kilogram per degree Celsius. Okay, specific for water is 4186 joule kg per kg per mol. Bukan per mol, per degree Celsius. Okay. Degree Celsius. Okay, specific for water. And the change of temperature kita, okay, change of temperature daripada final pergi ke initial, jadi kita akan dapat 80 degree Celsius. Okay. Okay, kenapa saya tidak ditukar unit daripada Kelvin? Because dalam kita punya specific heat for water, dia menggunakan unit degree Celsius. Alright. Change of T tadi kita adalah to 20 degrees Celsius minus 100 degrees Celsius. So we will get 80 degree Celsius. Okay, jadi tekan-tekan calculator. So you will get the Q, the value of Q is 4.19 exponent 4 joule. Okay, no, belum lagi. And the entropy, the change of entropy is 4.19 kuasa 4 over, dia kata over 20 because, okay, 20 ini you must change to unit in Kelvin. Okay, just add 273. So you will get 293 Kelvin. Jadi kita akan dapat 143 joule per Kelvin for the change entropy. Why kita menggunakan nilai 20? Sebab dia kata cools at room temperature 20 degrees Celsius. Okay, what is the change in entropy of the room? Okay, of the room tu maksudnya dia sudah degree dia adalah 20 degree Celsius. So this is the final value. Okay, that's all. Itu sahaja the example tutorial for chapter thermodynamics. So if you have any question, okay, you can contact me before the final exam. Okay, thank you and bye everyone.